With this lesson, we're going to begin simplifying algebraic expressions. As we get into this, we need to master some vocabulary. The first one is term. Term is a number, a variable, or a combination of a number and a variable. The example we have here is 3x squared plus 2x plus 6. 3x squared is a term. 2x is a term. 6 is a term. So how many terms do we have here? Well, there's 3 of them. A good rule of thumb is anytime you see a plus or a minus sign, there's probably another term there, at least one other one. But in today's lesson, we're going to need to really focus on this right here, like terms. Like terms are terms that have the same variables and raised to the same power. For instance, we have 2x squared and 3x squared. Another similar example to that is we have 4y and 3y. They're both the same. They have the same variable, and that variable is being raised to the same power. But what if I introduced another idea like 4y and 3y squared? Are those two like terms? The answer is no, because here we would consider this a y. It's a y term. This one is a y squared. And like we said in the definition, that the variables need to be raised to the same power in order to be considered like terms. So 4y and 3y squared, they're not like terms because a y is not the same as a y squared. And I'm really focusing in on that because that's something that you want to be able to recognize within a moment as you look at these coming problems. And then the last word we're going to look at here, though, is the term coefficient. Coefficient is a number being multiplied by a variable, or another way to look at it is it's the number in front of each term. Here we have 3x, where 3 is the coefficient. We have 2y, 2 is the coefficient. And we can actually do that same thing with all of these other ones that we've looked at so far today. With 2x squared, 2 is the coefficient. With 3x squared, 3 is the coefficient. 4y, the coefficient is 4. 3y, the coefficient is 3. So now that we're familiar with some of the vocabulary, let's start by just identifying which terms are like and which terms are not. Let's go through these. This first one is a 2x. Do you see any other terms that are some kind of x term? Well, this one has an x. Is this a like term? Well, no, because we wouldn't call this a 3x, it's 3xy. So if we were to name this, this is called an xy term, not the same as an x term. How about this one? 4x. Are there any other variables other than the x there? No. Is x being raised to the same exponent? Yes, it is. I don't see an exponent at all, in fact. So these are like terms. How about the 5y? Well, we don't even see the letter x there, so we know that one's not right. And then finally we have 6x. Again, the only letter we see is x, and we don't see any exponent. That implies we're raising it to the first power. So since our directions said to circle the like terms, we can go ahead and follow those instructions by circling the ones that only have an x, and no visible exponent. Let's do the same thing with this next problem. Looking at the first one, it's similar to that one, but this isn't an x term, it's an x squared. So that's what I want to start by comparing to. 3y, it's a different letter altogether. We know that one's not right. How about 4x? Is 4x a like term with 2x squared? Are the exponents the same? No, they're not. We know that this is not being raised to the second power, so it can't be that one. But how about 9x squared? 2x squared, 9x squared. Yeah, these two do match up, so we'll circle those in a second. And then finally we have 2xy. No, it has the letter y in it, so we know that's not the same. So as we circle the like terms, it's just these two, 2x squared and 9x squared. Another way to think of like terms is it's a lot like your last name. Maybe it's Smith or Jones. You can say you're in the same family with someone else, like your brother or your sister, who would have the same last name as you, Smith, or maybe it's Jones. Of course, if you have a hyphenated name like Smith Jones, well, you're probably only related to someone else who also has a hyphenated name like Smith Jones. It's another way to look at like terms as you identify them. So let's take a look at combining these like terms. I can go ahead and tell you this is a 3x and a 7x. They are like terms. We can combine them. And when you combine like terms, as long as they are like terms, meaning the variable and exponent is the same, it's going to stay the same. So we have an x, and then we just do what the operation says to the coefficients. 3 plus 7 is 10. Now we could do the same thing if this had been a 3xy plus a 7xy. The last name or type of term for this one is it's an xy. And this one is also an xy. They're still like terms, so the thing that makes them like terms, the xy, is going to stay the same in our final answer. And just like I did a moment ago, 3 plus 7 is still 10. And when you combine like terms, that's all you really need to do, is first identify if they're like terms, and then do whatever the operation says to the coefficient. So let's take a look at this problem. It says 2x squared minus 4x plus 9. We should start by identifying what types of terms we have. This one, we can call it an x squared type of term. Do you see any other x squareds in this algebraic expression? I don't. Here we have an x type term. Do you see any other terms that have an x? No exponent that you can see, just the variable x. I don't. And then finally, we have the number 9. A number by itself, we generally call that a constant, or just a simple number. Are there any other numbers that are not attached to any variables? I don't see any. So are any of these three terms like terms? No, they're not. So the answer to this problem is exactly what we started with, 2x squared minus 4x plus 9. What if we change that just a little bit, though? What if instead of it being 2x squared minus 4x, we changed it to 2x squared minus 4x squared plus 9. Are any of these like terms now? Well, now we have an x squared, like we did before, and we have another x squared. Now 2 of these numbers are like terms. So we'll leave the x squared alone, which is the thing they have in common, and we're going to do 2 minus 4, which is negative 2. And, well, 9 still doesn't have anything in common, so we'll just bring that down. And we end up with negative 2x squared plus 9. And that has simplified the expression by combining the like terms. And again, that's the most important thing. If there's anything you want to take home from this, is how to identify which terms are like and which terms aren't. Now this expression has a lot of terms, 6 of them in fact. 1, 2, 3, 4, 5, 6 of them. But it still works the same way. Let's start by looking at our first term. What type of term is it? It's an x squared term. So let's look over the rest of it and see if we can find any other x squared terms. That has a y. It's not an x squared. That is an x, but it also has a y. That's not it either. That one also has an x and a y. That one just has a y, there's no x. But this one has an x squared. They are like terms. We have 2x squared and 7x squared. Just like on the last problem, we look at the coefficients now. 2 and 7. 2 plus 7 is 9. 9 what? X squared. Let's move on to the next term. 6y. So what we're looking for is something that ends with y. No other letters, no other exponents, just the letter y. That one has a y, but it also has an x. That doesn't work. We already did this one. We don't even need to look at it anymore. There it is. Negative 4y. And notice that I said negative 4y. Whenever you're combining like terms and simplifying expressions, the sign that you see to the left of each term should stay with that term. This is a positive term, this is a positive term. When we get to it in a moment, we're going to see that this one is a negative term, and that this one that we're about to work with is a negative term because there's a negative sign or a minus right before it. So what are we going to do? We're going to do 6y minus 4y. Do the coefficients. 6 minus 4 is 2. 2 what? 2y. And finally, since we've eliminated all of the other ones, well, we can take a look and see. This is a negative 5xy, and this is a positive 9xy. Same 2 letters, same exponents. They're like terms, so we can go ahead and put them together. Look at the coefficients. We have negative 5 and positive 9. Negative 5 and 9, add them together, and you get 4. 4 what? 4 xy. And that's our final answer. As we combine all of these 6 terms, we ended up with 3 terms: 9x squared plus 2y plus 4xy. So let's put this into a little bit of context. Here we have a triangle, and we're being asked to write an expression for the perimeter of the triangle. Before we can get going on that, we need to remember what a perimeter is. Remember, perimeter is the sum or addition of all of the sides of your geometric figure. So in order to do this one, we're going to need to add together 4x plus 1, 3x plus 2, and 8x. And we're going to add all of those together. And just like the last problem, we start by looking for like terms. For x, do we see any other x terms? 3x, 8x. They're all the letter x, and they all have the same exponent, one that we don't see. So let's add those coefficients together. We have 4 plus 3, which is 7, plus 8, which is 15. 15 what? 15x. And then finally, we can do the same thing, looking for something common with a 1. It's a constant. There's no variable that we can see. We have 1 and 2, and 1 plus 2 is 3. Final answer, 15x plus 3. And that's the end of our lesson on combining like terms.